Oh, hello guys. Welcome back to the YouTube channel. So, in this live stream, we're gonna solve first, we're gonna understand. So, I'll give you the roadmap first. We're gonna understand what is functions and what are pointers. First, I'll start with function. What are functions? How we're gonna write a code using it. I'll give you a demo code also. Functions are very easy to understand. Pointers can later be a little bit tricky, but I'll help you to understand. And we'll write some code based on that. And yeah, this is the overall session for the day. Let's start. Let's start. I'll explain you all what are functions. So functions are basically a block of code outside the main code. So a function is like a int main, but it's outside the int main. I'll explain it much better when you see the code, but I'll give you a brief explanation. It's outside. So how do we call it? We call it using the function name in the main code. So you'll all be wondering, Sana, board code, what you're saying? Board. So I'm I'm trying to say is it's a block of code, reusable code. We can use it as a number of times. So yeah, let's get to it and I'll explain you all what it is. So I have a code over here. So outside the code, I initialize a function which would be void. So you all can keep it in. So I'll keep it in for now for your better understanding. Int will usually pass a number. Void can pass a string. So I'll use a void for now. Say teaser. So here's my void function, which is pizza. I'll turn that over here. That says pizza is very easy. Or I will say pizza is very tasty. So how do I call it over here? I call it using the name, which is pizza. And I'll say void pizza. So let's run it and see. Oh, wait, give me a minute. Oh, okay, I will use a void, which I don't know. I just have to initialize the name. So GCC board fit. You get pizza. Pizza is very tasty. I keep a slash n for better preference. So this is good. But usually this is not the cleanest way to write this kind of codes because these codes can mess it up. Sometimes they can be big enough, so you'll have 1,000 line of code, which can get mess. So we usually don't write like this. We do prefer initialize it first in the above and write the code below. So while is yeah, pizza tastes good. And we'll wind up this word compiler. So yeah, as you can see, pizza tastes good. Give me a minute now. So, so now I want to pass some variables to my function through the main code. How do I do it? I'll tell you. Now I'll say I remove this function. Now I say int, it's an add, initialize an add, keep this empty, this first use a printer, which says enter number one, and that's scanf, which is person the and, which is to initialize numbers over here also. So I'll say int n1, comma n2. So n1, then uh, this printer, I'll copy it down here, change this n2 and number 2. So yeah, okay, now the code is done for the main, so I'm passing the numbers to the other other functions. So I'll initialize the other function back over here. Add this. So now I'll take those values. For that, you can name in you can this is called a parameterized function. For here, we can pass any number, any variable. Like it will be a temporary variable. It can hold values. So x and y also. Now what it will do is I will initialize another variable which is result. Okay, so initialize it. So result is equal to the x plus y and return return the result to the main function. So return is usually used to return it to the main function. Return means it will return over here. So where it's gonna return? That's the main question. So to make it in its workings, I have to add that function over here, like I did for the pizza. I use a pizza function. Then I have to pass on the N1 and N2. So yeah, this is the thing. Then I can have to print or else I can okay wait I'll read the printer over here which is result okay sum is equal to the percent d and ni comma n2 and the one two answer is sum is 3. As you can see it is 3 where I'll give a better visual understanding but more people will get mostly confused. I'll give a better visual understanding of the flash and so yeah. You don't need this. I just wrote it for your reference. GC.c and it's the sum is 10. And that's beautiful. Finally, the code is working very nicely. So this that was a brief introduction of functions. How do how do they work? So there is another method for that, which is you can you can interact with in pointers. It will be a lot helpful. So yeah, this is the thing. Now let's read up this. And also there is you can pass function into a function, which can be very helpful. So I won't teach all that for now because it is very complicated. You all will get mostly confused with that. So I don't prefer teaching to you all now because it would need uh, a lot of patience for that. So I will won't teach you all. For now, I will just move on with this. So now let's start with some programs. Give me a minute. I'll come using the restroom. I'll come in a minute. Number. Let's start following codes. The first code of the day is uh, convert Fahrenheit convert Celsius to Fahrenheit. And Fahrenheit to Celsius. So yeah, let's begin with that. Uh, so let's start with that. Okay, wait, give me a minute. I'll display that formula. So to convert Celsius to Fahrenheit. So we want to convert Celsius to Fahrenheit. The formula is equal to formula is I'll write the formula right. I'll write the formula at the bottom. So half is equals to. So I'll ask the user for the Celsius and I'll write the code 9 divided by 5 and C plus 32. And to convert Fahrenheit to Celsius, so C is equals to half divided by 9 bracket Fahrenheit multiplied minus 32. So these are the codes. Okay, I'll write the heading also for other people to know. Okay, never mind. I don't think I'm writing it correct. Leave it. So yeah, now I will start writing the code. So it would be using functions. So I have to use functions for that. Oh, just have to choose between CNF and F and okay. Yeah, while writing the code, I will understand. So I'm done the setup over here. In C, comma, then uh, and Celsius, then what's in the okay, wait, not Celsius, and the choice. So the choice is percent C and choice. Now I went to choice. Okay, now I'll use if condition if the choice is equal to C, then return the Celsius program, which is cell, which I haven't done it yet. So wait for that. Else, else the Fahrenheit. Yeah, these are the codes. Now I have to calculate it. Calculate. You have to do the calculations. So I will use. I will initialize both cell and initialize cell, which is cell values to calculate Celsius. Celsius and the fact we use to calculate Fahrenheit. And so, which is uh, and ask for the user input over here. Or you can even ask over here. You can even ask over here the about this. You can like ask and pass the variable. It can be done like that. But better you ask over here. The function will look clean. And uh, sorry about the spelling. Okay, give me a minute. Let me check the spelling for Fahrenheit. Okay, I got the spelling very Fahrenheit. And then I'll just scan app over here to initialize some things. Create a fee which will be Fahrenheit. Personally, and actually, which is my Fahrenheit. Now, just have to calculate that. So, my C gas is cell, which is my cell. So, cell is equal to the uh, calculate cell. So, my cell is equal to the uh, 5 divided by 9 brackets the C, which is the Fahrenheit, minus 32. And I'll say return cell. So basically, I have to write a printf over here, put it in the printf, now C is equal to the person, the Fahrenheit. So yeah, to write for the to write the code for the Fahrenheit. So it is fair. Which so and I'll initialize both the same FE and cell. So now I don't want these now. So yeah, only need choice. So the same method, I'll just have to repeat this when I choose cell, cells, CEOs. Yeah, no, that's the. Oh wait, the answer would usually come in a float variable. So float, so I have to initialize it a float and initialize it float. And the person app, even here also initialize both as float because I will do get a float variable after the calculations, comma the and the FE. Oh, not a FE, C cell. So I got the cell now. Now I will calculate it with FE is equals to the 9 divided by 5, and then C plus, oh sorry, cell plus 32 and return the FE. So yeah, this is done. This is a board. See, wait. Yeah, I didn't use a printf for that. For Fahrenheit, I think so. Oh, I did. Let me check the code before running it. So can hashtag include main, which is the standard input output dot h. int cell, int slash 2, cell and wait, cell could, disturb. I've used a variable, so I will not use a cell. SCE, which is quite helpful. C, or else can you initialize it as C and RF? It depends on your what you all prefer. You can initialize any variable. So code typically correct. Okay, but I'll initialize if else if choice is equal to the f. Okay, so character expects a type of character and argument, but okay, I think so. I have glad int over there. I haven't forgot to change it. So yeah, that's it. I know. Okay, now I got some errors, which is comparison between a pointer and integer. So comparison between a pointer and integer. Mm, so yeah, we'll fix. Oh, I forgot that character usually needs works on a single port, which is a single port. So yeah, it works on a single port, and over here I forgot to put an semicolon, and forgot to multiply it both. So sure, I say I want to calculate Celsius to Fahrenheit, so I enter Fahrenheit. Wait, logic is wrong. Actually, I want to calculate the Fahrenheit. Want to I want Fahrenheit to Celsius, so I enter Fahrenheit, which is 30 degrees. Oh, it does do give me a zero. Uh, so initialize is both to float, Note and note. And better visual preference, I'll see. I He's a person over here. Yeah, good person there. I convert Fahrenheit to Celsius, so that enter Celsius. Oh, I wanna convert Celsius to Fahrenheit, so enter Celsius. That will be 34.23. Okay, no, it's working. It's working now. So I'll give you a last glance of the code, how it is. So this is the overall code. Y'all can copy someone. Very simple code, but do need a lot of complications. Uh, you should practice functions because if you use functions in your codes, then I have to repeat the same process again and again. You can, if in a large, this is a smaller code in large big module codes. There are certain parts where you have to repeat a certain process again and again. So to not repeat it back, we do use functions. Function, if you learn function, it would be a very helpful thing. Function usually doesn't interfere in the main program unless and until you program it. So I've programmed it so only when the character of C or the character or app has been entered, just do this functions, make these functions alive. And yeah, the program has just done what I have said. And yeah, this is the overall code. So now let's practice another code, which will be a calculator system where we add, multiply, subtract, then square, cube, root, and then sine, cos, anything. So it would be a fun thing to do. So yeah, let's start. Okay, okay. Usually sine and cos do need one number. So I don't think so. Cos or sine would need a calculator. But I'll try to add more to make this challenge. fun. So yeah, give me a minute. I'll come. So yeah, let's start the code. So stack include main. So this is the in main now. I'll take a stimulation over here. Stimulation means uh, I'll uh, I'll ask for numbers. Then I'll ask for add multiple cal. Let the user choose it. So okay, first I'll int one and choice. These are my three. Wait, no, I want no. I want let the function only ask based on what it needs. Because like if it is int, then float won't work. If it is unfloat, then it won't work. So I don't want to mess it up with that. Let the function asks, I'll just initialize choice. Okay, I just initialize choice. I'll use a while loop while while true. So now I will print a okay, first I'll display something. Printf. This would be my the menu, which is first I'll start with add, then I'll say subtract, then I'll say multiply, and I say divide, uh, square, uh, then we have cube and root. So I have just kept it like that. We'll add it more to it. So yeah, okay. Now I'll just make it a menu driven. Like I make a menu out of it. Menu. So yeah, this is the menu. And in the end, I'll add a one more slasher to make it look nice. I'll enter choice, which will be the scanner. This would be a user input. So SND. This would be choice. Uh, Now we're gonna use functions for that. So now I'm gonna use functions. So I'll just check and see if this code is working. Oh, okay. I haven't used a comma. Another way. Undeclared identifier. I would need this. I would need this to include this, which is std bull. Forgot to initialize it. So yeah, now let's start. Oh, you can see the menu. It looks very professional. Just have to add. Yeah, yeah. So let's start. Oh no, sorry, wrong command. So now I'll start using if else conditions. Well, can use a switch case. Switch case are usually one of the cleanest way to write codes. I can use a switch case also, but I usually don't prefer switch cases because you beginners do understand using if else a lot because if else are the main thing. So yeah, so if the if the choice is equal to the one, then perform this task for me, which is add. I haven't declared the functions right now, but I'm just normally using them for now. There's no harm in using without declaring. So I'll just use them for the structuring purpose because structuring is more important than because if you don't structure it properly, the whole code will go stub else. Now I'll just copy this and just paste four to four to three times, three to four times. Yeah. One, two, three, four. So yeah, let's say the choice is equal to the third one, which is multiply, which is mulch. And if the choice is equal to the 4, it is divide. And limit small short forms. If it is equal to the fifth one, which is square, and if it is uh, as if the choice is equal to the sixth one, which is cube. This is one of the smallest ones. Yeah, this is the last one, which is LL, else the choice is equal to the seven one, which is root. I all will get confused. Oh, bro, board just codes so long. No, it's not long. It is systematic. If it is long, it's not system. And if it is long and messy, it's not systematic. If it is long and systematic, it's the perfect. So yeah, I usually repeat things over here. So as per the dry rule, you shouldn't be repeating things. Do or don't always follow the dry rule. Do not repeat the codes always. I have done over here. I would have used a switch case. Switch case also would have not done anything much, but just to also have repeated the codes. So yeah, now I'm totally ready with working with functions. So now I start initializing function, which is add. Yeah, and I'll name it in one single line, four at a line, which is sub, which is mult, and which is div, and which is square, cube, root. I've initialized the functions over here. Now I will use it one by one. So this, okay, I'll just mark it that this is the end line of the main end curly bracket. So yes, let's start. Which will be okay. Before that, I'll initialize everything as float because user can type any number. It could be a float, it could be anything. So first only I'll initialize. Uh, so yeah, now I will ask for the user input, which is printf. Scanner printf is enter number one, percentage, not percentage, usually percent float n1 comma n2. And yeah, it's correct now. I have taken the input, so I'll just uh, declare another variable which will be total. So total is equals to n1 plus n2 and return total. So this is my float float add. So my add is done over here. There's nothing now to do for add. It's perfect now. It's perfect. So just have to repeat these things. Just have to repeat. I won't even change the uh, initialized variables. So and enter number one, number two. So minus done. This is for the float. If you all don't want to initialize total, also you all can what you're gonna do is return n1 minus n2. This is the most simplest form you can do. If I don't want to initialize that values and mulch, which will be times n times 2, return things. Yes, done. Which will be div. So this basically. Oh, I forgot to add a modulus also. Yeah, I can add a modulus in the end of the root just to have the user. Oh, yeah, we can add the fun thing. Now it is square, which will I have to. Okay, for square, I just ask for a single number. Oh, I can do sine, cos, and all. Okay, okay, I can do that. So n times n and return the total. Now it's the same process repeated for cube, where it will be n times n1, 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 n1 is linear cube. Now for the root, it's quite tricky for root. So to get a root, what we have to do is uh, divide that number with that. So wait, for a cube, I'll enter of number root which will be 49, 49, where 49 will get divided by 7. So square root of, I mean, square root. You can basically, one of the most easiest thing you can do over here is rather than struggling with that, rather than struggling with that, you can just include. For now, I just thought about how can I do it. And I said, why not use a math.h library? That's very, very simple. Just have to use that library. So now, what I'm gonna do is just initialize, uh, now just gonna use that square root for here. So when I enter that number, so it would be the square root SQR. Okay, SQRT something. When I forgot about that, then you have to just pass on the N1 and yeah, done. Return the total. So now I'll initialize another one, which will be a modulus. Forgot about that. Modulus is one of the important ones. So yeah, I'll say else if is equal to the H, then mod, one of the most simplest things. Oh my gosh, which would be um, modulus slash. We'll just add this and then okay, I've named it mod. Okay, why do I need this N2? N2 is not needed over here. One for over here, not needed. Then mod. I do need two numbers. So yeah, and number two, and percentage F, and the N2 and modulus N2. Uh, and, uh, addition is equal to the this. Get the percent F. Over here, and subtract percent F. Print F multiplication is equal to the percent F. Oh no, sorry. What is this? Divided. Division is equal to the percent F. Print F, which is square root square root square is equal to the percent F. Then printf cube printf printf, which will be square root square root percent f uh, printf modulus percent f. So yeah, now this is the whole code which I have just written in just things. So as you can see that the code is, well, I would have repeated the same process again and again, but now in that code, okay, invalid operand to binary have float and a float, okay, the 200 of it is square root, okay, understood. Mm, so yeah, and yeah, modulus cannot hold or cannot, cannot be a float. That's my mistake. Sorry about that. When I didn't know about that, I just knew now. Okay, yeah, I have read it about it, but yeah, no, I forgot. Sometimes you, as a human, you forget some things, which I will consider this as end. Then the main code, I'll change it. First and D about top, have to change it. It compiled, but it says in okay undefined square root uh, and a function root undefined reference to square root. Oh, so did I initialize it? Wait, I have initialized it, right? Let me just check. Let me check. I've initialized it, I guess. Oh, yeah, I did initialize it. Why do that? I think so. The error might be in the compilation, I guess. VCC mode of switch. I think so. The have to. Oh yeah, didn't use the LM because LM is needed. So yeah, one 3 plus 4, which is gives me 7. Correct. Now I want, let's say I want a root which is at the seventh position. And I want the root of 49, which is again a 7. I want the 8 virtual modulus. I want 8 modulus q, which gives me 0. That is beautifully correct. Now it is 4, so I want and 90 divided by a 45, which is me 2. Now I want to check subtraction. Subtraction is 4 minus 1, which is 3. And a multiplication, which is a 7 multiplied by 0.1, which gives me 0.70. That's beautifully done. I want a square, which I want a square of 9.6534, which gives me a square of 93.553391, and finally a cube, which I want a cube of 3.14, which is 5, 30.959148. So yeah, this is the calculator code. So for now, we'll take a short break, guys. We'll take a break of okay, wait. This is not this one. Nano voltage. Okay, now we'll take a short break for now. We'll recharge yourself. Okay, so we have more programs to do. So let's recharge ourselves. Let me first rub this everything, and then you'll take a 3 minutes break. Just relax, calm your mind. So so yeah, we'll take a break. I'll come in. So guys, I'm back. So, yeah, let's start. So as per my function, I will do a lot of programs in the future. So for now, I will start pointers and give a brief introduction to pointers now. What are pointers? How pointers are used? What they will do? How they can't. So yeah, let's do pointers now. So what are pointers? So the beginners usually have a lot of a lot of difficulty in this pointer. Well, and it has and the meaning of words is pointer the terminology that is actually why we refer it to pointers. So now why what are pointers? It reserves a space for the other to hold an integer value, like say example and int x. The int x is okay in x, so I'll just code and show you all include VIO knowledge. So yeah, this is the this is the function, main function. So like if a sorry, if the int x is equal to 3, so this x will have an address. So what is an address? Address is the location where it is stored. So C is a memory base, so where anything whatever you type, even if it is an printf, it has an address. It's just where it is stored into the memory of your system. So if I want to see where it is stored, where this X is stored, so I usually and just normally say show me the address. It will be percent %t slash m slash m. I'll pass on the X. So I use an and over here in the printer. Usually you never seen an and in the printer. Why I passed it because it is what when I started my life in the very beginning. I told you all this and is an address. It refers to an address. So show me the address of the pointer person P, which is a person P. Show me the and percent p. Show me the address of the x. So it's basically pointing to that address. This percent d is like pointing to that address. Show me that. So if I run it, so look, you all have this is an address. So this is an address of x. So there are different addresses. There are type of addresses, different addresses for an int and a float and a character and a boolean and a long double anything. There are multiple addresses. So you all don't have to buy hard these addresses. They are where they change as per the system. So the X is stored in this value, in this address. So if I access this address and I want to see the value, I can see that. That's why pointers do exist in C, and C is widely used for pointers. Because pointers is the only perfect thing, powerful thing in C. That's why C still exists because of pointers. Now, let's say I wanna check the address of the other. I'll initialize another, which will be a pointer, which will be a pointer. Why? Because I want to point something so that the address of the other variable comes to y. So I'll say, uh, give me a minute. So now I have to initialize, not initialize, so I just have to give the value give the address of x to y. And if I print j, if I want to see the address of something, let's say print as I'll remove, no, I'll not remove that. Print as address of I. If I want to see address of, sorry, not I, address of j, sorry, not j, address of x, address of x. So I'll address of x, which is equal to the pointer with which it will point. It will point that hey, my address is in j. So you can even access j if you want to see that. So it's basically like that. Then I will have to use an and y. Address of y will be is equal to address of g. This is the code that okay, okay. I will use a semicolon. Yeah. Address of x. Uh, sorry, address of y. This is an address of y. Sorry, my name is x. Sorry about that. We do make mistakes. So the address of y, which is which has its own value, you know, which has its own value. Address of x will be the other point. Sorry, it's correct that address of x will be equal to the address of y because we have initialized as y address is equal to the address of x. So yeah, now if I wanna get address of uh I'm sorry, I was not what I'm not. I want the address of y, and I'll have to check for the address of y. Now what I'll do, I'll switch them up. I'll switch them up. So here there's no sorry about that incomplete in inconsistency address of X. This is the address of X and this is the address of Y with their respective addresses at the end. So now what I'll do is uh, I'll switch them up. So what do you mean by switching? So address of let's say address of uh, I, well, sorry, address of X, which is equal to the person slash n. So this will also give so this will also sorry, this will also give width. So I want to print the value of I using the value of X using the Y. So I'll say the address. I'll say value of X is equal to the percent D slash n comma the I have to point use a pointer now pointer Y. So yeah, see, I got the same value over here because I use the pointer. Now I will show you another way. Now value of x is equal to 3 where I have used a pointer of y. So you can think about that like it's like a temporary variable kind of like the concept is like temp as to but over here it's like a very serious concept like memory, the addresses. It depends on that. I've just given an analogy about that, a temporary thing, but it's not a temporary thing, but it do depends on addresses, then your memory, and number of things. So yeah. So now what I'll do is I print the value of y. Printer. So if you also print the value of y, you'll get this thing. So okay, now I'll initialize another pointer for your reference, which will be and pointer z. So like z will be equal to the other y or the value of z will be equal to the person d slash n, the pointer z. This is the more let's see, more warning that it form operating pointer type. And now give me a minute. I think I have to use a double pointer, not double pointer, but it's that double, extracts. Use a pointer. I use a pointer, so I think so. It should be here over here. So it's showing it's wrong. Uh, yeah, so I think so that is the have to use a double. Yeah, have to use a double, I guess, like double asterisks. Well, I've read about that. I have to use a double asterisks. Yeah, I think so. Yeah, I would have to use. We have to put a point. I think so, and this would be a double. And so yeah, you can see the value of x is also 3. The value of z is 3 because the address has been passed. The address of the x has been passed, and the value of it is also passed. I'll show you z's address and everyone's address. So yeah, you can see this address of x, and this is the address of y, and this is the address of x, where the address of x will be passed to y, but y will have an individual address. So this address will pass it to contain a value which is 3. So yeah, 3 is printed, then the address of y which do contain 3 will be passed into j, and the value of it will be 3. So yeah, these are pointers, and we will try to solve some codes using pointers. I will try to, I'll try to, you, I try to square, you try to use square root for that, square root. So yeah, I, I'll say, and, I will say again, I'll assign a pointer, which is, uh, I, pointer. So now I'll pass on the value of pointer I is equal to the n. So I'll ask for the user input. Um, And yeah, now I have this diagram as a square is equal pointer. If we should be let I times 9 written uh, when initialize anything, right? After this is part of and so this would be basically those things because for initial element pointers, that's very discrete. So yeah, I think so. It should work. Or else the arrow might be in a square. That 100% that could be an arrow. I think so. There is an arrow. It runs well and good. Let's say I want number 8. Okay, it's working. And yeah, so as you can see that is a square using a pointer. So now another program which will be where two numbers using a pointer. So this will be the last code of the day. I'll wind up everything today. So I mentioned as variables and this will be the number one and then two and I'll swap swap and initialize two pointer variables, which will be a and I and a j. Okay, I'll just keep it I for now. With a third type over here, enter number one, enter number two, scanning over here, and number one, gonna and then two, boom. Now we'll swap when using pointers. So what swap will do is both will swap the applications. Uh, initial if they have to initialize it will be another in temp. Um, yeah, now and y is equal to n equal to and j is equal to and 2. So so now both are in a pointer. They have the addresses. How do I swap? Uh, it will be basically pointer and is equal to the pointer I pointer point is equal to the pointer I and so pointer I is equals to the I don't know guys what I'm doing. uh, let me think. Uh, with J and pointer C is equal to the pointer temp. So yeah, done. Now I don't know if it works for my logic. Sure. Yeah, it will be number one, which will be equal to the only comma the I. pointer I and pointer J. So yeah, it's basically like that old thing. I think so. I don't know if it will work because compile, let's say a 10 and a 20. So yeah, oh, it works. Nice, beautiful. Like how we change the memory location of it. So yeah, guys, these were pointers and functions for the day. So thank you for watching my stream. Hopefully we meet tomorrow. Sorry, we definitely will meet tomorrow. We'll solve pointer programs, more pointer program, more function program. We will combine pointers and functions. We'll do a lot tomorrow. So yeah, thank you.